So, fusion. What's a fusion? Imagine you have a piece of bone and you break it. There's a gap here. And literally bone grows from, first you create callus, and then the material here becomes cartilage-like material, and then it becomes literally bone. So practically the gap here gets filled, and then you know you have a fusion. In most of our body, bone is extremely, I would say, efficient, meaning that it grows across, and that happens in a few weeks. That bone grows across, and then it becomes stronger, become bone, so the gap goes away. But once the gap is filled, bone, once the pressure is practically managed by amount of the bone is growing, our body is very efficient, it stops growing more. Now, sacroiliac joint is extremely different because it has very little motion, and literally, and it's the gap in the sacroiliac joint, this is iliac crest, this is sacrum. This gap, you cannot expect for the entire gap to be filled. As a matter of fact, we did a study where we put a regular solid screw. We measured that if you grow just few millimeter, 2 to 3 millimeter outside of that, that's enough to immobilize this very, very rigid joint. And that's enough. So few millimeter is enough to stop the motion there, and that's called fusion for sacroiliac joint. Now, if a radiologist expect all this gap to be filled, that will never happen in the sacroiliac joint. Now, what will happen as well in the sacroiliac joint, that this material, the screw that we put in, most of the time is titanium, and one of the characteristics of titanium is that bone grows into the titanium, meaning that literally if this is one bone, this is the other bone, and there is titanium screw across, bone grows into the titanium, and screw itself becomes kind of a part of fusion. What happens if the fusion doesn't happen? Then you have the gap, you have the hollow around the screw, then you know that this bone has not grown into this. So meaning that a year or year and a half, 2 years later, if the screw is not loose, independent of if the gap is filled or not, this material is part of the fusion and practically becomes the fusion. Now, it get even more interesting because when we put a so-called hollow screw, a screw that practically has a huge hole inside, most of that fusion happens actually inside of the screw, meaning the bone that grows inside of the screw, and then we have side screws here and so on, meaning that not only bone grows into titanium, bone actually grows inside of the titanium, huge hole, and since this is not a very mobile joint, that's enough for definition of fusion. And that is why there is this controversy that even if they don't fuse, patient still does well. It is because our interpretation of fusion is wrong, and the fusion does happen. Inside of the screw is a hollow screw, and with the connection of the bone to the screw. That's why most of the system, they have this titanium, and some system they have this porous material, like 3D printed porous material that the bone grows inside, and the metal become part of the screw. Now, in our paper, what we showed with this solid screw that doesn't have the hole inside is that this patient, if they just few millimeter bone grows, patient does well. If it doesn't grow and there's a hollow around the screw, patient clinically doesn't do well. So practically in sacroiliac joint, contrary to a long bone where you are looking for the gap to be filled, you look for sign of non-fusion. If there's no sign of, this is practically the difference. In sacroiliac joint, if there is no sign of non-union, meaning hollow or the gap around the screw, mobility, clinical symptoms, then you know there's a non-union. If after a year or two is a solid screw in a solid bone and the patient has no symptoms, that is practically assurance that the fusion has already happened.